Okay, we're doing example from 5.5 on how to use substitution to solve integrals. Now when you look at something like this, you might think, oh my gosh, where do I even start? Well, that's where substitution comes in handy with integrals, because unlike derivatives where we can easily attack them one at a time, we really can't do that with integrals, so you need substitution. And what you do is you pick a part that's going to be your u. It's going to be what you substitute for. And now what you usually do is you look at the different parts and you pick the higher exponent, because you're going to take the derivative of it, and the derivative is going to make it one less. So I'm going to pick this part here, and I'm going to set that equal to my u. And then what I'm going to do is I'm going to take the derivative, so this becomes du. So this becomes negative 4 x to the third dx. Now what I have done here is then I have broken this into parts. So you can see this x to the third dx, that's right here. So then I'm going to move this. Then I have negative 1/4 du, and I've just moved it to the other side, x to the third dx. And then here this is going to become u. So what I'm doing is I'm taking all my different parts. My goal is to get rid of all the x's and dx's and turn them into u's and du's. But I have to make sure I get all the different parts. So like this negative 1/4 can go out front because it's just a coefficient. So this over here, this is my u, so this becomes 1 over u squared. And then my x to the third dx, that here, becomes this negative 1/4 du. And I put the negative 1/4 out here, and here's my du. So now I've changed this big equation into this, and this I can easily integrate. I'm going to rewrite this because I prefer to work with negative exponents. So I'm going to add 1, and this will become negative 1. So I have 1/4, the negatives cancel each other out, and I have u here to the negative 1 plus c. So that's 1/4 over 1 over u plus c. And then I'm going to just go and put this back in. So I have 1 over 2 minus x to the fourth times the 4 out here. So, and then I can, if I wanted to, I could multiply this through 1 over 8 minus 4 x to the fourth, and then of course plus c if I wanted. So you can see I have the plus c here. So 1 over, and let's see what did I have. I had, and it likes to disappear these whenever I go back, 8 minus 4 x to the fourth, okay, plus c, and check my answer. So you can see substitution helps take a messy problem and make it simple. The hardest part is deciding what is your u and then rearranging your du so that you can get all the different bits and parts. Pick something. A lot of times whatever is in the parentheses is a good option, as well as thinking about always picking the largest exponent. And remember, if the u doesn't work out, you get a du and you look back and go, this isn't going to work, start over again, pick a different u, and try again. For the most part, we're trying to keep these simple, so don't try to think really complicated, but definitely look at this and go, okay, I have an x to the third up here, an x to the fourth up here, let's first try the x to the fourth. If that doesn't work, I'll try something else.